All right, so this little lecture is going to be about the periodic table. The periodic table is something that is very useful in chemistry, and a lot of the things that we're talking about in Chapter 2 actually are found in the periodic table, not necessarily who found an electron or who found a proton, but the protons and the electrons and average atomic masses and lots of other different things are actually incorporated into the periodic table. So we're talking about the periodic table now. It is something that there's a lot of terminology associated with, and so it's useful to know that terminology so that you can manipulate your way around the, or maybe not manipulate, navigate your way around the periodic table, and just have a familiarity with what people are talking about when they mention different things, okay? The periodic table that we have, there were lots of different people who were trying to figure out a way to order all these different elements that have been discovered in the late 1700s and the 1800s. The one that we actually have was developed by a guy by the name of Mendeleev in 1869. Okay. Now, other people were looking at just masses, or maybe things called triads, where, three different elements that all kind of behaved similarly. What Mendeleev did was he arranged things. He looked at trends in both the weight and the properties. Okay, so he didn't just look at the weight, or he didn't just look at the reactivity, or, how many hydrogens they tended to have on them or whatever. He kind of combined everything together. And so he went by increasing weight, but then he started grouping things together based on properties. And if something didn't match up, then he was fine saying, you know what, we're going to flip-flop this weight around. And even though this is heavier, it's going to go before the one that is lighter. If there was something that just didn't make sense in terms of the properties, he would leave a space blank and say, you know what, this is probably just an element that we haven't discovered yet, and I can make some predictions about what that element is going to look like, where we're going to find it, how heavy it's going to be, what its density is going to be. And it was that ability of Mendeleev to skip over elements and make a prediction as to what that element would be like, that made his periodic table very, very useful. It was predictive. And so it didn't just have the elements, it had the elements in an order that could be used to make sense of the elements that were discovered. The periodic table we have now doesn't really look like his. We have a lot more elements, but that idea was discovered by Mendeleev. Okay. The one thing that is a little bit different, at the time that Mendeleev created his periodic table, they do nothing about protons, okay? So it turns out that the trends are really not based on the weight or the properties. It is a periodic function of the atomic number. So he didn't know about protons, but actually the elements on the periodic table increase with increasing atomic number, which was mentioned before. So hydrogen has an atomic number of 1, and so it is the first one. Helium has an atomic number of 2, lithium 3, beryllium 4. So 1 proton, 2 protons, 3, 4, 5, 6, 7, 8, 9. So we're increasing our elements based on the number of protons or the atomic number. Again, Mendeleev wouldn't have known that, so he wouldn't have made that type of periodic function. Okay. So when we are talking about the periodic table, there are lots of different things that we can consider. The first thing, one of the big ways of distinguishing things, is based on periods and groups or families. Okay. Periods are not necessarily within one period. It is not necessarily always the same, but the idea of a period is something is repeating over and over and over again. It is cyclical. It repeats. Okay, and so it's not the same within the period, but as we go from the first period to the next, to the next, to the next, those different properties, those different trends are repeating themselves over and over and over again. Okay. Families. When you think about a family, for the most part, you think about things that are similar. Okay. Periods have differences, but within them, but families are similar within them. So I do not look exactly like my brother or sister, although people thought my sister and I were twins when we were younger. But we have same hair color, roughly. I'm the lightest. The others are a little bit darker. But no one's like black hair. We all have lighter hair. We all have blue eyes, same face shapes or cheeks or eyes or, maybe heights. Some families tend to be short. Some families tend to be very tall. So there are similarities within a group or family that allow us to identify them. Say, oh, you must be a whoever, okay? And so those periods and groups are found on our periodic table, okay? The periods are actually listed on the side. It says period, okay? The periods are the rows. And so period 1, 2, 3, 4, 5, 6, 7 refer to row number 1, row number 2, row number 3, 4, 5, 6, and 7, okay? And the idea with the periods is that as we start a new one, the properties are repeating themselves. So lithium is very similar to sodium. And so when we start the new period, we have similar properties again. Potassium is very similar to sodium. So when we start the new period, we have similar properties. They end very different than they started. Neon is very different from lithium. Argon is very different from sodium. But when we end, they're very similar. So this period 2 ends with neon, period 3 ends with argon, period 4 ends with krypton. Neon, argon, krypton within that period are very, very similar. Okay. The reason why they're very, very similar is because those are our families. So as we go down a column, those are going to be our groups or our families. Okay. So our groups and our families, those are our columns. Our periods, those are the rows. Okay. So that is one way that we can talk about them. Another way we can talk about the periodic table is to talk about different types of elements. And different sections of the periodic table. So one way we talk about different big sections of the periodic table is based on kind of peaks and valleys, okay? So we have this part here in the middle that drops down, okay? It drops down here, it drops down more over here. When you look at the labels here for the different columns, these all have B's on them. Okay. These are ones that are sunken down. We also have the part here that sticks way up. So these two over here, these 6 over here. Okay. These ones that stick up, these are what we call main group or representative elements. Okay. Some of them were the ones that were kind of discovered earlier on. They have properties that are much more consistent, and so a lot of reactions and stuff are done with them, and trends are discovered with them. And so those are our main group or representative elements. The ones that fall farther down, those are our transition elements. Okay, also known as transition metals. So our main group of representative elements have the A's after the old-fashioned column headings, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. The transition elements have the B's, all right? I will say our periodic table has both Roman numerals and this just 1 through 18 going across. That's because different countries did the A's and B's differently. So in the U.S., we do the main groups as A's, the transitions as B's. There's some European countries that do the main group as B's and the transitions as A's. And so they just decided we'll just go 1 through 18 across. Okay, but we do talk about the A's and the main group ones. The one other section, I mean, technically it is down here. The transition elements are these 10 rows going across. When we drop down here, these two on the bottom we call the inner transition elements or inner transition metals. Okay. The way this periodic table is set up, okay, they kind of come before the transition elements. Some periodic tables, and there's a debate as to whether the first two here, lanthanum and actinium, really belong down in the inner transition elements, or if they belong up here where 71 and 103 are. And so sometimes this part comes kind of before, and sometimes it comes right kind of here in the middle. Okay, so inside the transition elements. But either way, it's our inner transition elements. Okay. And so that is another way that we have of talking about it. If I am looking at oxygen, okay, I can say that oxygen, that is a main group element. Or if I have ruthenium, ruthenium is a transition element. If I have gadolinium, that is an inner transition element. So having these different classifications of main group element, transition element, inner transition element provides a way to kind of break things down more. Okay. Within the periodic table, there is, what color do I want to make this? I'll do orange. There is this stair-step line here. And the stair-step line is used as a way to kind of divvy up the periodic table into two halves. Okay, one half over here is where the metals are. The other half over here is where the nonmetals are. Okay, and metals versus nonmetals, that is based on pretty much the properties that they have. So metals, we've all seen metals. Okay, those are things that tend to be solid, at least at room temperature and pressure. The only one that is different is mercury, which is a liquid. They are what we call ductile, which means we can stretch them into wires. They are malleable, which means we can pound them into sheets, which is how we have, like aluminum foil and tin foil and stuff like that. They tend to be shiny, lovely shiny objects, and they conduct electricity and heat. Okay, so those are some of the main things about the metals. The last main property of the metal is that when they make ions, they tend to lose electrons. Okay, big thing about them. And so when we look at the periodic table, all of these elements that are over here to the left of that stair-step line, and I probably should include the little line here, hydrogen is not a metal. Okay, so we kind of extend that stair-step line over here. So everything down here, lithium, beryllium, all the ones, the transitions, the inner transitions, all of those are what we call metals because they all have those properties of being shiny and malleable and conductive and all that other kind of stuff. Okay. The ones to the right of that stair-step line, those are what we call the nonmetals. And our nonmetals are basically a mess. Okay, there's lots of different properties, but the main thing is that they don't have the metal properties. It's a lot harder to give generic properties for them because some are solid, some are liquid, some are gas. So there's a lot of variation. The one thing that they all do tend to do is they do tend to gain electrons to make ions. So our nonmetals are going to gain electrons. They're going to be negative. I had a prof who went nonmetals are negative, like a little robot way back when. But nonmetals gain electrons to make ions, so they are negative ions. Our metals are going to lose electrons, so they are going to be positive. Okay? So we have our metals, we have our nonmetals, right? We also kind of have the border, okay? If we are right smack dab on the border between the metal and the nonmetal, it's really hard for an element to just stop. Okay, we're a metal all the way up to this point, and then we're going to immediately switch over. And so we have this area kind of on the interface, not every single element, but a lot of elements on the interface. And I'm just highlighting them here. Boron, silicon, germanium, arsenic, antimony, tellurium, astatine, which we consider metalloids, okay, or some books call them semimetals. But these ones are the metalloids. And so we would say that they are actually on the stair-step line. The only ones on the stair-step that are not would be aluminum and polonium. Those are going to be metals. The polonium, some books say it's a metal, some books say it's a metalloid. But I believe this version of Tro says that it's a metal. So we're going to call it a metal. But our metalloids, when we look at the metalloids, these have some properties. Of the metals. But they're either not as strong or they're not all there. So an example would be something like silicon. Okay? Silicon we use as a semiconductor. So it can conduct. If you've seen a piece of silicon, it is shiny. However, it behaves a whole lot like charcoal. So if you were to smash it, you wouldn't get a lovely sheet of silicon. You'd get a bunch of silicon fragments. Okay, when they make wafers of silicon, they're depositing silicon atoms or they're slicing sheets off. You can't just pound on a lump of silicon and get a nice sheet. Okay, so it has some of the properties of the metal, not all of the properties of the metal. Okay, so when we are talking about things on the periodic table, we can describe it as being a metal or a nonmetal or a metalloid. Okay. Last thing to mention. Oh, we did say that our elements, our metals are going to lose electrons, nonmetals are going to gain electrons. The main group, metals and nonmetals, tend to make ions with the same number of electrons as our noble gases, which we'll talk about in a second, but that is column 8A or 18. Okay. So, some different, very broad classifications of our different elements. The other thing we can do, though, is we can start to talk about much, much smaller categories. And usually when we are talking about our smaller categories, we are going to be talking about our groups or our families. Again, there's similarities, and so, you know, well, this is the McMurdos, or this is the Joneses, or this is the Smiths, or this is the whoever, okay? We like to give names for different families that we come across over and over and over again. It makes a nice way of talking about them, okay? And so, realistically speaking, there probably are names for pretty much every single column on the periodic table. However, some of them we just don't use that much. Okay, so you are only going to be required to know the names of the ones that we see more often. Okay, so some of the different families that you should be aware of. The first column, okay, column 1, okay, these are metals, okay, and when you think about lithium, sodium, potassium, maybe not rubidium, lithium, sodium, potassium, some of you have seen the video where they throw the sodium in the water and you get this big flume of water, gas, stuff like that. They make bases, okay? The resulting solution is going to be basic, which another way of saying that is that it is alkali or alkaline, okay? So that first column is called the alkali metals because they tend to make bases when you put them in water, okay? You don't really find chunks of sodium or lithium or potassium laying around because they do react very violently with water, okay? They're basic metals, but we don't really see the metal itself laying around. Okay. The second column, column 2 or 2A, those also will make bases. Magnesium hydroxide is a base. Calcium hydroxide is a base. But the metal itself is a little bit more stable. If I drop a piece of magnesium in water, it's not going to go boom, okay? In my mug that I have all the pins in, I have some pieces of magnesium in there usually because they're not as reactive. We can find chunks of magnesium on Earth. So these still do make basic things. They are basic or alkaline, but we can find them on Earth. And so column 2 is called the alkaline earth metals. Okay. Now, as we continue our way across, then we come into the transition metals, column 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or 12. And again, we probably have names for some of these. If you are doing, in-depth magnesium or manganese work, so manganese, technetium, rhenium, borium, you probably know the name for that column, okay? In general, most of us don't, okay? So we're not learning the names. Although, you should recognize that there are similarities. So if I am doing copper, okay, silver, gold, those are all elements that we use to make jewelry. They have some very similar properties that are very useful in making jewelry. People who do iron research usually just stick with iron, but then you get heavier, ruthenium, osmium. It's not quite as prevalent, but ruthenium and osmium all do similar types of chemistry. So you either focus on the top one, because it's much more prevalent, or you focus on the bottom pair, okay? So we don't have names for these columns, but they still do have those familial attributes to them, okay? As we continue on over, columns 13 through 18, or 3A through 8A, again, there are reasons why these elements are in the same, the same column, okay? But as we're going down a particular row, if I'm looking at row 14 here, column 14 here, I have a nonmetal. I have a pair of metalloids. I have metals. And so just the properties of the nonmetals, the metalloids, the metals are going to be varying a lot. And so we don't tend to really give them names as much because we're either dealing with the top or the bottom, not the whole particular column. Okay. So we don't start really looking at names until we get over here much farther along. Group 17 or 7A, whichever one you want to call it, this is what we call the halogens. Okay? They tend to exist as pairs in nature, so you never find single fluorine by itself. It's always F2 or Cl2 or Br2 or I2. And they're all nonmetals except for the astatine at the very, very bottom. And so we can deal with the halogens as a group, and we're pretty much always dealing with nonmetals. Halogens tend to form salts, so we find them a lot in nature in all of our different salts, right? Column 18, or 8A. As I said, this is what is known as the noble gases, okay? They're the noble gases because, number one, they all exist as a gas in nature. And noble because when they were first discovered, they couldn't find anything that they would react with, okay? And so they were considered the haughty noble elite of the periodic table. They're not interacting with anyone else around them. And so they were called the noble gases. The last possible groupings, we do have little columns with our intertransition metals, but these are little columns of 2, okay? Not really very useful to talk about a column of 2. And so with our intertransition metals, that is the one thing where we actually don't talk about columns. We actually talk about rows, okay? And so the top row is called the lanthanides, okay, because they start with lanthanum. The bottom row is called the actinides because it starts with actinum, okay? So, A variety of different ways to talk about the periodic table, name things on the periodic table. You should be familiar with all these different names and positions and things like that. So, you can look at magnesium. Okay, magnesium is a metal. It's in period 3. It's an alkaline earth metal. Okay. Sulfur, selenium is a nonmetal. It's in period 4. Yeah, not much else on that one because we didn't talk about chalcogens. When you get done viewing this, there should be a quiz that pops up called Periodic Table Assessments, and that will be due by the next class period.